Okay, in this video lesson what we're going to be talking about is detecting radiation, and I'm also going to introduce the concept of half-life. Okay, so we've talked about what radiation is, but we need to talk a little bit about how we measure it and how we deal with it in the laboratory. Okay, hopefully everybody knows the universal symbol for radiation there. Okay, so let's take a look at the tool that we use for measuring. Hopefully you know what this is. You might have heard it, might have seen it in movies. Geiger counter. Geiger counter is the instrument that we use to measure levels of radiation. So this is the machine that makes that clicking noise. You may have seen me use it in class already. If not, you will see me use it in class. But essentially it's the thing that makes that little ticking noise and accounts for the number of particles. This was invented in 1908 by Hans Geiger. Essentially the way it works is you have this electrical wiring hooked up and set up in here, but there's no connection between the wires, so there's no completion of the circuit. So what happens is as inside of this tube is a gas, okay, and there's these atoms of the gas are floating inside of the tube, and there's this window, and the radiation can come through the glass, can come through the little screen that they have at the front. And as it comes through, it has really high amounts of energy involved in it. So what it does is as it hits these atoms, it knocks electrons off. So the idea behind the Geiger counter is that these radiation particles, which are electrons or alpha particles or positrons, whatever they happen to be, well, technically not positrons, but anyway, when it comes in, it knocks the electron off. The electron hits the anode, which is a piece of wire, and it causes an electrical impulse to go through, and boop, you get a little bleep on your machine. Okay, and that's essentially how the Geiger counter works. It's the high energy of the radiation knocks electrons off to complete the electric circuit. Okay, now one thing that we need to talk about, and we're going to talk about more in another video, is something called half-life. Half-life is essentially the amount of time that it needs, that a sample has in order to break in half. Okay, now this is just one observation that was made about radioactivity, is that all elements have their own half-life, and it seems like it's predictable as to how much time will go by and half the sample will be gone away. So for astatine-218, the half-life is 2 seconds. So every 2 seconds, so if we just ignore that and think of this as seconds, every 2 seconds half of the sample will go down. So let's say we start off with 400 nuclei of astatine. Well, after 2 seconds, we'll have 200 of them. After another 2 seconds, meaning 4 seconds, after 2 half-lives have gone by, we'll have cut the sample in half and cut it in half again. So we'll have gone from 400 to 100 in about 4 seconds. Add 2 more seconds, we go through 3 half-lives, and we cut it in half again. And if we continue on and we go to 8 seconds, you can see that this would be 25. And we get a curve, a line, that's going to be very predictable for these samples. And every one of these is going to have a curve just like that. You're going to plot this on a graph. What you would end up with each and every time is a curve that looks like this. Every time. So this would be your number of nuclei up here. And down here you would have time. And they always look the same. And as you know from your math class, you could probably get an equation for this line, and there's there is a mathematical equation. We're not going to go into that much. We're going to look at the equations and going to talk about the calculations of half-life on the next video. So that was detecting radiation. I know it's a short one, but I don't really need to go into much. I want to separate out the equation part from the introductory part. So thanks.